In this video, we are going to learn how to find the exact values of the trigonometric functions at 30, 60, and 45 degrees. Now, quick trig review is we're going to go over how we typically find the values of these trig functions, which is right triangle trig. We need first identify what's the opposite side of the angle that we're referring to. In this case, I represented it by theta. The adjacent side and the hypotenuse, which is always opposite of the right angle. Now that you know these sides, we can go through our acronym SOHCAHTOA, which for sine would be opposite over hypotenuse. For cosine would be adjacent over hypotenuse. Wrote that in the wrong spot. And then for tangent would be opposites over adjacent. Now, there are three other trig functions, so in case you haven't learned them yet, they're referred to as cosecant, secant, and cotangent. And they represent the other combinations of like opposite, adjacent, and hypotenuse. Typically, the reciprocals of the ones they are across from now. So cosecant is the reciprocal of sine, which will be hypotenuse over opposite instead. Secant will be hypotenuse over adjacent. And then cotangent will be adjacent over opposite. Which if you try to use an acronym like SOHCAHTOA with cosecant, secant, and cotangent, it is CHO-SHAKOW. So if you say it all together, it's SOHCAHTOA CHO-SHAKOW. It's a mouthful. But now let's go over the exact values of the trigonometric functions. First, of 45 degrees. Now, using a 45, 45, 90 triangle, we know there's certain ratios that the sides exist in, meaning if the two sides here, since it is a right isosceles triangle, were 1, the hypotenuse would be the square root of 2 by Pythagorean theorem. But now knowing this, the cosine, let's look at this 45-degree angle, would be opposite over hypotenuse. So the opposite side would be 1, and the hypotenuse would be the square root of 2. And if I were to rationalize my denominator by multiplying the top and the bottom of the fraction by the square root of 2, I would get the square root of 2 over 2, which is the exact value of sine of 45 degrees. Usually if you plug that into your calculator, it would be this long decimal that doesn't repeat, but now we know for sure that it's the square root of 2 over 2. Cosine would be the adjacent side, which is 1, over the hypotenuse, which is the square root of 2, which also, when rationalized, gives me the square root of 2 over 2. So it means that sine of 45 and cosine of 45 equal the same value. Now tangent, we know, is opposite over adjacent, would give me 1 over 1, which just simplifies to 1. Pretty straightforward. And cosecant, now we know that as the reciprocal of sine, but just using our definition up top, is the hypotenuse over the opposite side. So the square root of 2 over 1, which just simplifies to the square root of 2. Secant has a very similar solution. It is going to be the square root of 2 over 1 as well, because opposite over adjacent, which also gives me square root of 2. And the cotangent of 45 degrees would be adjacent over opposite, which would also give you 1, like tangent. And those are the exact values of those trig functions, which is a pretty powerful thing to say, since most of the time when I use trig functions before trigonometry, there are always some like crazy decimals that I had to deal with. But now let's look at 30 and 60. And if you want to, You can pause this video and see if you can fill out the rest of this without me. But if I was looking at 30 degrees, I know that there is something called a 30, 60, 90 triangle, which with ratios, which if the opposite side of 30 degrees was 1, that makes the hypotenuse 2, and the opposite side of 60 degrees, the square root of 3. And I can use these to find the values of sine of 30 degrees, which in this case is going to be 1/2. Very straightforward. Now you'd think with the pattern we saw in the last one that maybe cosine would be the same value, but it is not. This time it's going to be the square root of 3 over 2. Tangent of 30 degrees is going to be opposite over adjacent, giving me 1 over the square root of 3, which when rationalized by multiplying the top and the bottom by the square root of 3, gives me the square root of 3 over 3. Cosecant is going to be opposite, hypotenuse over opposite, so 2 over 1. Hypotenuse over opposite, which simplifies to 2. Secant of 30 degrees is going to be hypotenuse over adjacent, so 2 over the square root of 3, which when rationalized by multiplying the top and the bottom by the square root of 3, gives me 2 square roots of 3 over 3. And then cotangent of 30 degrees will be adjacent over opposite, which gives me square root of 3 over 1, which simplifies just as the square root of 3. Again, very specific values for something we thought before to be this very randomly generated decimal. Now for 60, we're going to use the same exact triangle, just focus in on the 60 degrees. You'll probably see some similarities in values just because we're still using all the same like length sides. So sine is going to be the square root of 3 over 2 for opposite over hypotenuse, which is very similar to what cosine was in the previous angle. So it seems that sine of 60 degrees is equal to the cosine of 30 degrees, which is very interesting. Cosine should be adjacent over hypotenuse, so 1 over 2, leaving me with 1/2, which again mimics what sine was in the previous example. So cosine of 60 degrees is the same as sine of 30 degrees. We will discuss in further detail like where these patterns come from in the future, or just take note of it now and you'll be ahead of the game. Tangent will be opposite over adjacent, giving me the square root of 3 over 1, which is just the square root of 3. Cosecant of 60 would be hypotenuse over opposite, so it would give me 2 over the square root of 3, which when rationalized, that denominator, I get 2 square roots of 3 over 3. And then we have secant, which will be hypotenuse over adjacent, give me just 2 over 1, which when simplified just leaves me with 2. And then cotangent of 60 degrees would be adjacent over opposite, give me 1 over the square root of 3, which when rationalized leaves me with the square root of 3 over 3. Now you know how to find the exact values of the trigonometric functions at 30, 60, and 45 degrees.